In this chapter, we will see how to implement commitment control in RPG programs. To set up a commitment control environment, we need to perform the following steps. Identify the files that are involved in complex transactions. The programs must be modified. The files must be journaled. Begin commitment control before starting the application and end commitment control when it is no longer needed. In this chapter, we will look at step 2. The F specifications for the files that are to be opened under commitment control must be modified to include a commit continuation option. The next step is to identify the transaction boundaries. A transaction starts when the first record is read from a file that has been opened under commitment control and ends with a commit or rollback operation. Commit indicates the completion of a transaction and causes all the changes to be applied to the database. All the records that have been updated will be unlocked and a commit entry will be made to the journal. Factor 1 of a commit statement can contain an identifier that is used for restart information. Rollback causes all the changes for the current transaction to be removed. All the updated records will be unlocked and an entry made in the journal receiver. The rollback function can also be issued explicitly by the system if the commitment control function ends for some reason and there are uncommitted changes. Let us study the program. The file description specifications include the commit continuation option for the two files. The program prompts the operator for input. It then proceeds to update two database files with the input data. The commitment cycle begins with the first chain operation. The record from the first file is read and updated. If this operation was successful, the record from the second database file is read and then updated. If both the operations were done successfully, the commit operation is performed. Otherwise, a rollback operation will be performed. A rollback operation will also be performed in case the operator ends the job in the middle of a transaction. All the records will remain locked until the commit or rollback operation. Next, let us look at a notify object. A notify object is an object that can be used as a source of restart information when recovering from a failure. The commit identifier entry on the commit operation is used to supply the information to be placed in the notify object. You can use a database file, a message queue, or a data area as a notify object. A data area can contain information about a single failure only. A message queue can hold many messages, but it cannot be saved, and it is also difficult to retrieve a particular message at random. Database files do not have any such limitations, and hence it is the best choice for a notify object. The object has to be identified on the start commitment control command. A notify object is automatically updated under the following circumstances. When uncommitted changes exist in the journal and commitment control is ended normally through the use of the end commitment control statement or a normal end of job occurs. If either the job or the system ends abnormally after the first commit boundary, the notify object will not get updated. When there are no uncommitted changes in the journal and commitment control is ended normally through the use of the end commitment control statement or a normal end of job occurs. if either the job or the system ends abnormally before the first commit cycle is complete. Let us look at an example. A database file is used as a notify object. Here we include all the fields that will be needed to restart the application. We have the fields used in the transaction itself: account number, installment amount, installment number. We also include fields that will identify the job that processed the transaction, such as username, job name, and system date. We can also use a field to identify whether the failure occurred during the first cycle. In the program, the F specification should include an entry for the notify object. Since the commit identifier will contain the same data as in the notify object, an externally defined data structure that is based on the notify object database file is used for the commit identifier. A program described data structure is used to provide the username and job name. When the program starts executing, it will set on an indicator to signal that first cycle processing is being done. The program will use this indicator later. The program will then check the notify object to see if there are any entries related to this user. An entry indicates that the previous termination was abnormal. If a record is found, the cycle field is checked to see whether the error occurred in the first cycle, in which case the prompt screen is displayed to the user with an error message. In case the error did not occur in the first cycle, the data in the notify object is used to display the details of the last successful transaction to the user. If the indicator that identifies the first cycle processing is on, the program initializes the cycle field to 1, writes this information to the notify object, and resets the cycle field to 0. Now, normal processing continues as we saw in the previous example. The commit identifier specified on the commit operation causes the information contained in the commit identifier to be written to the journal along with the commit journal entry. Before the program ends, it deletes all the entries in the notify object for this job. This completes our discussion on commitment control. Summary. In this chapter we saw how to implement commitment control in RPG programs. We also saw how the notify object is used as a source of restart information.